Hello, and welcome to Lesson 3 of C.1, the Polar Ice Unit. I'm Meijin Chia, a high school teacher using OpenSciEd and an OpenSciEd facilitator. In this video, I will give an overview of Lesson 3 and wrap up with some tips and tricks. Lesson 3 is a fun lesson for students as they get to conduct a hands-on investigation where the data from each lab group contributes to what we are trying to figure out regarding the effect of atmospheric carbon dioxide concentration on temperature. First, let's recap on how we got to Lesson 3. At the end of Lesson 2, we conclude that the increase in atmospheric carbon dioxide concentration due to human activities such as burning fossil fuels and deforestation is the most likely cause of the recent rapid increase in global temperature. In this lesson, we are wondering, how does an increase in atmospheric carbon dioxide concentration cause an increase in temperature? Let's take a look at this lesson at a high level. Lesson 3 takes 3 45-minute days. It involves a hands-on investigation, the carbon dioxide lab. The 40 minutes of material preparation listed here is mainly to prepare the materials for the carbon dioxide lab. Students do not need to use their individual devices unless you would like them to explore the atmospheric carbon dioxide reading using their own digital copies. There are 2 lesson chunks over the course of the 3 days. In the first lesson chunk, students gather data from the carbon dioxide lab and figure out that when atmospheric carbon dioxide concentration is higher, there is a greater increase in temperature when there is energy input into the system. In the second lesson chunk, students model how carbon dioxide as matter changes the flow of energy leaving a closed system. Through a reading, students realize that atmospheric carbon dioxide has a long-term impact on global temperatures. So in summary, on day 1 of lesson 3, from the model closed bottle system, students have evidence that an increase in atmospheric carbon dioxide concentration in the presence of energy source result in greater temperature increases. Then on day 2, students reason that the carbon dioxide in the atmosphere affects energy flow. When there is an increase in atmospheric carbon dioxide concentration, the energy that enters the system is less likely to exit the system. Finally, on day 3, from the atmospheric carbon dioxide reading, students realize that since carbon dioxide reduces the amount of energy that leaves Earth's system, and carbon dioxide stays for a long time in the atmosphere, reducing carbon dioxide emissions alone will not be enough to address sea level rise. We need other solutions. Let's take a look at the key moments in Lesson 3. On day 1 of this lesson, students are provided with the carbon dioxide investigation procedure. Using this procedure, the class collaboratively identify the investigation's variables, generate a directional hypothesis and the reasonings behind the hypothesis using the concepts of matter and energy, and structure the data table. Now, in my first year teaching this lesson, I made the rookie mistake of assuming that all students would know how to identify variables and set up a data table. Constructing the investigation anchor chart that I show here on the slide with students is definitely worth the instructional time. Students conduct the carbon dioxide investigation on day 2 of this lesson. I modified the investigation to more closely mimic the food experiment that is referenced on this slide. 3 lab groups conduct their investigations with heat lamp, while 3 other lab groups conduct their investigations without heat lamps. This provided evidence that when the Alka-Seltzer tablet dissolves in water, the chemical reaction that generates carbon dioxide does not release energy. There must be energy input from the heat lamp to see a greater increase in temperature of the air inside the bottle system when the atmospheric carbon dioxide concentration is higher. Now, teachers have reported difficulties with getting this experiment to work as expected. So I'll talk more about how to navigate these challenges in the tips and tricks section. In part 9 of lesson 3, students practice using the energy transfer rules to visualize how carbon dioxide as matter could affect the flow of energy in the closed water bottle system. They then apply these findings of higher atmospheric carbon dioxide concentration somehow reducing the energy exiting the closed system to the Earth system. Since students now have many questions regarding atmospheric carbon dioxide, they complete a reading about atmospheric gases where they are introduced to various concepts, such as concentration and the enhanced greenhouse effect. They find out that carbon dioxide stays in the atmosphere for a long time, which lead to continued increase in global temperature and hence sea level rising. At the end of lesson 3, we update our driving question board and circle back to the anchoring phenomenon by wondering how much sea level would rise at each of the different scenarios predicted by scientists. Okay, let's talk a little bit about some strategies for this lesson. For the carbon dioxide investigation, I found that it was less messy to close the bottle with a cap that had a drilled hole for the digital thermometer to fit through, as I show through the pictures here. After positioning the thermometer, I used hot glue to seal the hole around the thermometer to reduce leakage of carbon dioxide. To generate sufficient carbon dioxide without overpressurizing the bottle, lab groups used one Alka-Seltzer tablet for the low carbon dioxide scenario and two Alka-Seltzer tablets for the high carbon dioxide scenario. For the energy transfer model in lesson 3, the teacher edition showed the bottle and carbon dioxide as objects within the bottle system. I modified the objects to carbon dioxide and thermometer within the bottle system. I wanted to emphasize that it is the carbon dioxide, not the bottle itself, that reduces the amount of energy that can exit the bottle system when the concentration of carbon dioxide inside the bottle's airspace increases. I also wanted to draw the analogy that we can observe that there is more energy inside the bottle system because the thermometer measures a higher air temperature. And when more energy is kept within Earth system, then there is more ice melt. In lesson 3, the investigation anchor chart records the definition of independent, dependent, and controlled variables that students should add to their personal glossary. Through the atmospheric carbon dioxide reading, students co-construct the meaning of greenhouse effect and also encounter other words such as concentration, mixture, solution, and greenhouse gases. They encounter the terms input and output when considering energy flow into and out of the closed bottle and Earth systems. So we start the investigation anchor chart in this lesson and add to the energy anchor chart. Both of these charts will be used in future lessons because we keep adding to these charts. Well, this is lesson 3 in a nutshell. The carbon dioxide investigation can be tricky, but it is a great lab to scaffold planning and conducting an investigation with students, plus students do enjoy the lab. I hope you find this helpful and join us again for lesson 4, where students calculate the estimated sea level rise due to polar land ice melt and conduct an investigation to find out whether sea ice melting affects sea level rise. Thank you.